Welcome to Hosting Drupal on Kubernetes. I'm your host, Tess Flynn, and we're going to explore how to host Drupal on Kubernetes. First question you might have is, this presentation has links in it, so you might not necessarily know where to find all the information. All the information is already online at github.io. So why don't you take a minute to actually go ahead to that URL. It is the word 10, the number 7, .github.io/hosting-drupal-on-Kubernetes. Okay, let's move on. If you actually need help with this course material while you're going through it, we actually do have a channel on drupal.slack.com. It's called #10, the word 10, the number 7, -K, the number 8, S-class. So 10.7K8's class, that channel will actually allow you to get some help when viewing this class, okay? All right, after that, there's a number of different units, and we're going to just go through them one at a time. So the first one we're going to go to is Hello K8s. So let's talk about skyscrapers versus skylines. That sounds a little bit strange, but you'll get what I'm talking about pretty soon here. So let's say that you're an operations person and your product owner bursts into your office and they're already having a bad day. And why are they having a bad day? They're having a bad day because their server is on fire. Why is their server on fire? Your product owner says, "Help! Our site's running too slow." And of course, you're an operations person. You're there to make everything work very smoothly and well and fix problems. And you'll say, "Sure, I'll just add more CPU and memory to this particular server." And everything's fine for a while. And then later, "Help, it's slow again. Can you make the server bigger again?" And then this time it gets to a little bit of a problem because you've already made the server bigger and now you have a much bigger server, which means a much bigger problem. This is what's called scaling up. Scaling up is a very old-fashioned resource management technique within computers. It adds resources, that is CPU and memory, to the server, and it's the oldest capacity management method that we actually use today. There's a number of limitations with this, however. Hardware can only get so big, usually because of time, money, or even technical reasons. Some servers, I've actually read an eye-opening report one time that x86 architecture limits or starts going down in performance after you add more than 16 CPU cores. Now that report was probably 5 or 6 years ago at this point, and there might be some technical innovation since then, but it does suggest that not always adding more resource fixes everything. Sometimes you need to take an alternate strategy. So let's go to an alternate universe where we have the same conversation between ourselves, the operation person, and the product owner. "Help! Our site's running too slow." This time, however, instead of deciding to add more CPU and memory to make the server bigger, we decide to add more servers to power the application instead. Now, this is great and it solves the problem, but later on we discover that it creates other problems. You might be sitting there one day and having a perfectly good day, having your coffee, and your product owner comes to you going, "Hey, what's gateway timeout mean?" And suddenly you have to debug a very complicated application that is between multiple different servers and multiple different tiers, and you know that it's going to be a very, very long day. This is what's called scaling out. It adds more servers to the application, sometimes multiple servers to the same part of the application. You may have multiple front-end servers running a web server. You may have multiple back-end servers running a database server. Those kind of things can be a scaling out opportunity. Now, scaling out isn't perfect either. It has a number of limitations itself. It requires application re-architecting. It can be difficult for humans to manage or troubleshoot because the more servers that you add, the more complex your application becomes, and now you not only need to figure out what the problem is, but where in your entire cluster of servers that problem is. Because not all servers, even if they're identically provisioned, will work exactly the same way with traditional management techniques. There's always some minor difference that messes things up. So let's leave that problem on the shelf for a moment and let's talk about a different problem. So you're the operations person, you're having a conversation with a developer for the application that you're working on, and your developer is having a bad day. They just don't understand why the application works on their system when they're testing it and developing it, but it doesn't work for whatever reason in production. And then you look at their screen and immediately notice that they're running a newer version of X, some library, some piece of software, something that's different on their system compared to what's on the production server. And then a tumbleweed passes between the two of you, and you know exactly what kind of question is going to happen next, because they're going to ask, hey, can we put that same version on prod? And now we have a huge cluster of multiple servers with different versions, and they all have to have this new version deployed, and you know it's going to be a very long day. This is basically dependency management. Dependency management isn't just for code. It's the entire application. Libraries, versions, key configurations. Co-hosted applications that reside on the same infrastructure can have conflicting requirements. How often do you have an application where you have a Drupal 7 site that absolutely must say on PHP 5 for whatever reason, and you can't move it to PHP 7, which is all of your other sites? Now you have conflicting requirements, which means you have to do a lot of additional dancing in order to make that application function correctly. One solution that has emerged to combat this problem is containers. Containers package the operating system with the application itself, so all the dependencies are managed as a single cohesive unit. Docker has emerged as the premier containerization solution. It's a popular container toolkit because it simplifies the underlying container details, and it has really, really strong developer support. You can find tons of tutorials online about how to work with Docker, what Docker is, how Docker works, and you can figure out how to actually add Docker to your toolkit. So, why not just use Docker and prod? Why do we mess with this Kubernetes thing? Well, let's talk about clustering containers. If we want to cluster containers manually, it requires really deep knowledge, because not only do we have to worry about clustering the various servers together, but now we have a virtualized application which is not aware of the clustering environment, which also has to be clustered together, which means network configurations, a whole bunch of dependency management, and a bunch of other things that become really complicated in order to manage. And it's really difficult for us human beings to do this manually. We can spend entire weeks troubleshooting problems and finding solutions and working with this configuration to stand up on the application. And it's simply too slow. And half the reason why is there's just so much to manage. Provisioning, resource limits and access policies, network, firewall, load balancing rules, health monitoring, because we want to make sure that if one part of our application goes down, there's some immediate remediation so that we can actually sleep at night, and tons more other stuff that we just haven't had the ability to wrap our heads around. And because operations teams today are so small, managing all of these things as an individual or a small team becomes a very, very difficult task. So, wouldn't it be great if there was a unified way of doing all of that, so that we don't have to mess with 15,000 load balancer configurations, tons of networking details across disparate distributions of Linux, and a whole bunch of other stuff? And there is. And that's where Kubernetes comes to the rescue. Kubernetes is actually a container orchestrator. It doesn't actually run the containers. It coordinates multiple hosts, which unfortunately for us Drupal people are called nodes, insert groan here, to act as one. So we have all of these nodes in our container cluster that act as a single cohesive unit, and the orchestrator stands over all of that in order to make sure that instances are deployed correctly, that load is distributed properly, and that resources are made available necessary to run the application. So it acts as a watchful eye to make sure that all of these resources are there and available for your application to run. Kubernetes is also open source, which is a huge benefit. Originally, it was created by Google out of their Google Borg project to run their own data centers. A lot of internal lobbying was actually done by Google employees to open source the best components of Borg, and that became Kubernetes. Today, it's maintained by the Cloud Native Compute Foundation, and you can find all of the code available on GitHub. The thing that attracts me the most to Kubernetes is expressive power. Pods are only one manageable object within Kubernetes. This allows you to tailor Kubernetes to your application, not the other way around. This is different than, say, a Docker Swarm solution, where Docker Swarm seems to have the inbuilt idea that you're always working with custom applications no matter what, which means you have always the ability to modify the application to suit how Docker Swarm works. This doesn't really work for us as Drupal people, because Drupal, in a lot of cases, we kind of treat as a black box with some well-defined edges. That's really how we tend to treat Drupal, and this makes it very difficult to run it on Docker Swarm without heavy modification. Fortunately, because Kubernetes is much more flexible, we can tailor Kubernetes to Drupal rather than the other way around. This makes it so that it's a lot easier for us to deploy Drupal on Kubernetes and get all of these other benefits. When we interact with Kubernetes, we're actually going to interact by defining objects in declarative YAML. If you've worked with Drupal 8 already, you've probably worked with YAML. It's an indent-based markup format that contains a whole bunch of information. It's kind of like XML, but it's only indent-based and has a simpler syntax. It's declarative rather than imperative. Now, this is something that some people might not necessarily know what the definition is. Imperative is do this, then do this, then do this. Now, the problem with do this modalities is that you don't know what the initial state of what the thing you're doing to is. So if you do this, this, and this, you only know for certain that those things were changed. Declarative means I don't care what the individual operations are. This is. I'm going to describe the end result of what I want, and then I don't care how the infrastructure makes that happen. Just make it happen. Also, all this declarative YAML can be live edited, patched, and diffed. It's a lot like Git, so it's really, really comfortable to work with when you're actually coming from a more developer background than an operations background. It's also very, very terminal friendly. The kubecontrol command, and there's actually a few different ways of pronouncing this, the kubecontrol command is the single point of entry to work with your cluster. It's a single point of access. It plays well with scripts and automation. Now, like I said, there's a few different ways of pronouncing kubecontrol. There's kubecontrol, there's kubecuttle. There's a whole bunch of different pronunciations. Do the one that makes you giggle, because life is too short to be arguing about how to pronounce a weirdly shaped command that's missing letters. Now that we know what Kubernetes is, where do we actually use this thing? The first and most obvious option is that we can self-host. This is a lot more work, but you control everything. This may be your only option if you're a hospital, a government organization, or a school, anything that has a dedicated on-premises data requirement, in which case you do have to consider self-hosting. This requires dedicated staff in order to maintain. Do not approach this with a single individual that is meant to stand it up once and never touch it again. That is immediately a bad practice, and you will regret it the next time there's a major security problem with Kubernetes. Be very careful about this. Always have a dedicated staff to maintain your hosting if you are self-hosting. Furthermore, with Kubernetes, you need one additional server in addition to all of the other servers that manage your workload. This manager node does all of the different work in order to do the orchestration bits, the coordinating, the orchestrating, the provisioning. This server is necessary in order to work, and you do need to actually specify a dedicated system that will not have any other workload running on it. Installation of Kubernetes is actually not too difficult. I did this once in an afternoon over a weekend because I'm bored and I have no life. So first of all, go ahead and install Docker and the Kubernetes agent called kubelet. Then install some utilities. kubeadmin, which is an administration utility for managing clusters, and of course kubecontrol, because we need that too. Then we need to install a container networking interface. It's called a CNI, and this is actually a pluggable network mechanism which allows different containers to talk to each other across physical servers transparently. There's a number of different ones that Kubernetes supports. I happen to choose Calico because it's open source, it installs really easily, and the icon is a cute cat. And that's very, very important when you're doing things on a weekend. Next, you can use kubeadmin to stand up the cluster, and then after that, you have a cluster. And there's a whole tutorial on this on Linode docs. Now, there's an important caveat with this. Kubernetes does not install as a secure by default configuration. A lot of the permissions require additional post-installation configuration, so you have to do that yourself. Furthermore, storage becomes a bit of a concern. This requires additional infrastructure for Kubernetes, usually like a SAN or some kind of NFS server. And NFS servers are very common, and certainly you could use one if you want. If you have one available, go nuts. Do that. It's known management techniques, a known proven technology that you can plug in, and it will work, and it does work with Kubernetes natively. But there are more native storage mechanisms that you could use, such as Ceph, Rook, or Heketi. Each one of these is got more options for doing Kubernetes cloud scale storage compared to NFS. Now, you might be going, that's a lot of work, and I really don't want to self-host. I don't need to self-host. Can I just pay someone to do this for me? And the answer is yes, you totally can do this. This is called managed hosting. Now, this field is actually pretty new, but it has exploded in the last couple years. We now have seen dedicated Kubernetes-flavored managed hosting providers. It's like a virtual private server, but for Kubernetes-only workloads. Typically, you only pay for the worker nodes, not the manager node, and storage is already baked in for you, so you don't need to worry about configuring that yourself. There's a number of different providers for this. There's Amazon, Azure, DigitalOcean, Google JKE, and a whole bunch of other providers. There's a huge list of them on Kubernetes docs that you can examine yourself. For this class, we're going to be using DigitalOcean. They're a worldwide Kubernetes provider. They have a really straightforward REST-based API that you can interact with just using the curl command. Seriously, just the curl command. You don't need a special CLI in order to do this. And it's really, really great. So let's see how to create a cluster. So first of all, we have to, do some planning. Yes, planning's no fun, but we always should probably do some capacity estimation first. And the reason why is we don't want to shoot ourselves in the foot. Newer servers are actually a lot easier to add in Kubernetes. So if we do need to actually add additional capacity, it's not that big of a deal in Kubernetes. Kubernetes assumes that the environment, the server environment, is not static, that you will add servers or take away servers as your workload demands. And there's even auto-scaling abilities built into Kubernetes that you can take advantage of. How many servers should we make our cluster? Typically, the minimum is at least 2 worker nodes. And the reason why it's 2 worker nodes is you need one to run your workload, and if that one crashes, you have a backup. That's it. That's the minimum, the bare absolute minimum for a production workload. 3 or more is better because you can leverage more containers, more workload, more resources. And the more that you can afford, the best. What about CPU and memory? Honestly, today we don't need to do complicated algorithms and a whole bunch of estimation in order to figure out exactly what we need. In general, I tend to go with a more gut approach today, and that's because in managed hosting, we have a lot more ability to dynamically allocate more resource as we need. So it's much more effective to balance the hosting costs with the needed resources. So start with the resources you need to run your application right at this moment, and times it by 128 25%. This will give you enough wiggle room to allow you to make sure that your application will run for the next several months, if not the next year or two. In all of this, flexibility is actually one thing that Kubernetes gets you. Scaling out is a lot easier on managed Kubernetes, and it is an expected thing that you're going to do. So plan, but not too hard. All right, now that we got the boring planning out of the way, how do we actually allocate this? Typically, this is done at the hosting provider level. We don't actually allocate physical servers using Kubernetes. Kubernetes only works with a cluster that is already stood up. So we need to talk to the hosting provider in order to actually stand up that hardware first. So usually we can do this via a web portal, an API, or a dedicated CLI application. Never do we do this in kubecontrol, because again, kubecontrol only interacts with an already running cluster. So how do we do this with the API? With API and DigitalOcean, we can do a post of a JSON request using curl. And there's a number of different ways we can do this. They have documentation, we can look at it. If you're using Ansible, however, you can use the 10.7.DigitalOcean role on Ansible Galaxy in order to allocate the cluster for you. And it has a really, really easy format that's well documented on that page. So go ahead and take a look at that if you use Ansible. But for today, for this class, we're going to keep things really simple and not throw in an unnecessary tool yet. We're just going to use the web portal because it's very straightforward. So we go to cloud.digitalocean.com, we use our login to log into DigitalOcean, then we hit the big green Create button and select clusters. How it looks like is that there's a big green Create button at the upper right-hand corner of the screen. That will open a pop-up. Scroll down until you can find the entry for clusters and click Clusters. This will take you to another screen. In this screen, what we're going to do is first we're going to select the Kubernetes version that we're going to create. Typically, you want to use the latest version that DigitalOcean supports because this will have the most security patches available for it and will be the most up-to-date version. You can update this version later if you need to, but it does require some downtime. So choose this very, very carefully. Next, we want to choose a data center region. There's a number of different regions available for Kubernetes on DigitalOcean. Pick the one that's most physically proximate to you and your visitors. If you happen to be like I am in Minneapolis, you might want to use the Toronto region because it's the most geographically proximate to where you are. After that, you need to choose a cluster capacity. Now, if you've ever worked with a virtual private server service before, typically you allocate one server at a time. You say, I need one server, it has this much memory, this much CPU, and that's it. When we allocate clusters, however, we have to extend the concept. We don't allocate one server at a time when we're allocating a cluster. It's much better to allocate a group of servers that all have the same resources at the same time. This is called a node pool. It's not a Kubernetes concept, but I have not seen a Kubernetes hosting provider which doesn't call it a node pool. Every node in the pool has the same exact memory, the same exact number of CPUs, and usually is assigned a particular pool name. And DigitalOcean is no different. Enter a node pool name. This is actually important because it can be used later in very advanced configurations. So choose a pool name that is clear and understandable. Then select the machine type. Usually I just select standard nodes because most Drupal workloads just need an acceptable balance of CPU and memory. It doesn't really need too much of one or the other. Now, if your application is particularly different, use your own knowledge. Don't listen to me. Then afterwards, select node plan. There's a number of different available here. Select one that balances with your resource needs and your budget. And then select the number of nodes. And one thing that's really, really nice about DigitalOcean is the price is listed right there, dynamically right on the page. You can't really get this from a whole bunch of other Kubernetes hosting providers. You basically have to wait for a bill. It's really frustrating, and it's one of the main reasons why we like DigitalOcean. Once you've selected your node pool, you can enter some tags. This is a DigitalOcean thing. You don't need to do it. And then choose a name for the cluster. And do yourself a favor, choose a short name for that, because you're going to be entering this a lot in the succeeding labs for this class. So be very careful with that. Then afterwards, go ahead and click the big green Create Cluster button, and in a few minutes, you'll have your cluster. Once we have our cluster up, we can start using kube control. So first of all, where do we get kube control? Well, there's multiple different options, and they have different pros and cons, depending on which ones you want to choose. The most simple direct one is called using the dist, basically an archive. It installs only the needed binaries, only kube control, and it's typically already compiled for your platform. You can find this at kubernetes.io/docs/tasks/tools/install-kube-control. Another way is to use a package manager. If you're using Homebrew on Mac OS, Chocolatey Scoop, or PowerShell Gallery on Windows, this might be a good option. At the time of this writing, the version of kube control in Homebrew lags several versions behind what's on the dist, so this might not necessarily be the best option for you. So use that very carefully. But the advantage of using a package manager is that it tends to keep it updated with your operating system. Just keep in mind if the package manager itself doesn't have the version updated itself. If you're using Linux, this is pretty much your default. You're going to use whatever package manager your distribution uses, and that's perfectly fine. Another option is to use Docker for Mac or for Windows. If you're already using Docker for Mac or Docker for Windows, you probably already have kube control installed on your system. It's included with it out of the box. And typically, that's not so bad, because Dockers tended to you need Docker in order to develop containers to put on your Kubernetes cluster. So it's a pretty good match. The only downside is that the version of kube control that's included with Docker for Mac and Windows tends to also be several versions behind, and this can cause some weird API compatibility issues which look like user error, but they're not. They're version errors. So in general, for the first time, I highly recommend that you use the dist first. It's very easy, it's the newest version, and you'll definitely be sure that it will match your cluster version as well. The other downside for using the kube control version that's included with Docker for Mac and Windows is if you don't have Docker already installed, it's a huge download. It's a gigabyte in size. Don't do this over a hotel connection or a cell phone connection. Not a good idea. And also, it requires you to register for an account. And yeah, sometimes you just don't want to give that information out, and that's perfectly fine. You don't need to give any information out to download the dist. Once we have the binaries on our system, we need to authorize our system to talk to the cluster. There's a number of different ways that this can be done too, all depending on hosting provider. So you have to look at how the hosting provider does this. It could be a CLI command. I know that Amazon does this. I know that Google does this as well, an authentication token. Some providers require you to have an authentication token. DigitalOcean uses a kubeconfig file. Now, what's the kubeconfig file? The kubeconfig file contains a number of information, including an authentication token and also some certificates, in order to grant you access to the cluster. How do we get this? Actually, it's pretty easy to do this through the web UI. Go to cloud.digitalocean.com, go to Manage Kubernetes, and then click the Download Config file. It will look like this. Now you'll notice that the Manage Kubernetes is in a pane in the left-hand side of the screen. So that's where you're going to click that first. And then the Download Config file button is going to be over here on the right-hand side. When you first allocate the cluster, however, DigitalOcean likes putting a huge splash screen right under your cluster name, so that button tends to be down on the bottom off screen. So make sure you scroll up first if you can't find the button. It's there. It's probably just underneath everything else. Once you have that file, you're good to go. Now, the problem with this file is that DigitalOcean regularly re-rolls the kubeconfig file every 24 hours as a security precaution. So after a while, that file becomes stale and it expires, and DigitalOcean will have to re-provision you a new file. And this is not good if you want to plug it in to some automation like a continuous automation system. As a result, you probably want to get the kubeconfig file via the API instead. This is much better for scripts and automation because you get a fresh file every time that you're going to interact with Kubernetes. Now, you can do this in a number of different ways, including going ahead and accessing the API yourself manually, or if you're using Ansible to run your automation, you can use the 10.7.digitalocean_kubeconfig role on Ansible Galaxy to download this file for you. Another way of doing this is to use a service account. Kubernetes actually maintains its own user account system inside of itself, which is really useful for authorizing things like constant users or particular applications which need greater user access rights to manipulate and modify the cluster itself. So the problem with the service account is that you need to get into the cluster in the first place to create the service account. And this is also a really advanced option. Once you create this, this has security implications that you are now responsible for managing and not your hosting provider. Now, the reason why I bring this up is not so that you can use this as a default, but mostly that you know that what that thing is that you're thinking of is called a service account. That's why I bring it up here. Okay, what about kubeconfig and kubecontrol? Now we want to use it. What does that look like? Every kubecontrol command takes this form: kubecontrol verb object. So let's say we want to list all the worker nodes in our cluster. So what command we're going to use is kubecontrol get, which is the verb, nodes, which is the noun. So kubecontrol get nodes, and we get a list of all the nodes in the cluster. What if we want more details? We want to describe a particular node in our cluster to get more insight into what's going on. Well, turns out it's kubecontrol describe node, and then the name of the node itself. This lists status, CPU, memory allocation, and a whole bunch of other information, which is very useful for you to figure out what the load is on your system. So that's it. That's our first unit. We're now going to have the first lab. The general overview of the lab is going to be you install kubecontrol, you create a cluster using the web portal, then you're going to download the kubeconfig file, and then you're going to interact with the cluster. And that's what our lab is. All right, let's go.